Okay, in this podcast, I'm going to go over two of the problems in Quest 3. On this problem set, it's number 1 and number 5, although your numbers are going to be different in the problem. So let's take a look at what we have. So it gives us an equation. It says, what's the maximum amount of iron 2-phosphate? So we're trying to figure out the grams of this. That we can be formed with 9.15 grams of iron 2 chloride and 12.02 grams of sodium phosphate. Okay, so because we are told so first of all, first thing we always have to do when we do stoic is balance the equation. I always like starting with the polyatomic ions because this is a phosphate over here. And there's 2 of them. I've got to have 2 of the sodium phosphates, which means I'm going to end up with 6 sodiums, and because I have 6 chlorine, I need 3 of those. Okay, so that should make it balanced. Now, in this problem, I'm told how much iron chloride I have and how much sodium phosphate I have. And any time I am told the starting amounts of 2 different reactants, I have a limiting reactant problem. And if I want to know the maximum amount of the product that can be made, I have to look at how much I can make, how much of that product I can make with each one of these. And whichever one ends up being the least amount is the amount that will actually be made. So all I have to do is I take my 9.15 grams of FeCl2, and I'm given the molar masses, so it makes it pretty easy. So it's 126.751 grams is 1 mole of FeCl2. Then I have to use the mole-to-mole ratio, and what I know is 3 moles of FeCl2 are going to give me 1 mole of iron 3-phosphate, or iron 2-phosphate. And I'm given the molar mass for that, and that's 1 mole of that is going to be 357.478 grams. Okay? And if I take all that and multiply it out, I end up with, I'm going to get 8.602 grams here. Then I'm going to do exactly the same thing with my 12.02 grams of sodium phosphate. And what I know, or what I'm told, is the molar mass is 163.941 grams, is 1 mole of sodium phosphate. And the balance equation tells me I have 2 sodium phosphates for every 1 iron 2 phosphates. And I know the molar mass of the iron 2 phosphate again is 357.478. And when I multiply that out, what I get is 13.105 grams. So I can make 13 grams from the sodium phosphate. I can only make 8.6 from the iron 2 chloride. So the only thing I can make is what I can make with my limiting reactant. So the answer to that is going to be 8.602. All right, let's take a look at number 5. And so it says that we have a reaction between 9.7 grams of fluorine with excess chlorine producing 7.7 grams of chlorine trifluoride. What percent of yield of ClF3 was obtained? So this 7.7 is my actual yield. And if I put that over my theoretical, which is what the stoichiometry gives me, times 100, I'm going to get my percent. Oops. Alright, I'm getting too close to the end there. It's going to give me my percent yield. Now, the thing that I suspect is causing most people difficulty is the balance equation. What you have to remember is I'm using fluorine and chlorine, and both of those are diatomic. There are 7 diatomic, and you have to have those memorized. And it's going to make ClF3. Alright, so I'm going to need 2 of those, 3 of those, and that should be good. So if I have 9.7 grams of fluorine, and the molar mass of fluorine is, F2 is going to be 38 grams, is 1 mole, and I have 3 moles of F2, give me 2 moles of ClF3, and 1 mole of ClF3 is going to be 92.45 grams of ClF3, and that's going to give me 15.733 grams. So my percent yield is going to be my actual over my theoretical. So that's going to be my actual. What I got was what they told me, 7.7 grams. And the theoretical that comes from my stoic is 15.733. And if I take that answer and multiply it times 100, what I get is 48.94% yield. Okay, so I need the extra decimal places to give that answer, and have Quest give it to me as correct. But we only want 2 sig figs in our answer, so if you're doing this in your notebook, which you should be, that'd be a 49% yield. Okay. Hope that helps.